So I wanted to put together a quick video here, both showing you how to use MyMathLab to graph these parabolas, but also to give some more information about an aspect to the parabolas that I did not work into my notes, which I apologize for. And that was the concept of what's called the lattice rectum, which is a way to determine the approximate size or shape of your parabola beyond just the vertex. So I'll be using this example here. Notice with our x squared quantity and our y quantity, there is no plus or minus, there's no h or k. So we're going to know that our vertex is centered at 0, 0 at the origin. With the vertex at 0, 0, the next thing we need to determine is the value for p. So we know that in this form, you'll have your squared quantity over here, your linear term or quantity over here, the 36 out front, right? This is that value that's supposed to be equal to the 4p. So dividing 36 by 4 would give me a p of 9. Now, here's where you can use the formulas that the notes have printed or that the MyMathLab videos will kind of plug into. I'm much more a fan of just making sure you understand the very basics of how these work, to where if you see an x squared, this is what I mentioned in our notes when I went through them. If you look at the x squared, you know you're dealing with a parabola that opens like all the parabolas we've been used to up to this point, meaning that U shape up or the U shape down, one or the other. So with that being said, if you know this is a U shape up or down, you look at this 36 and it's positive. Positive tells you of those two options, it's going to open upward. And then, again, that value of p being 9, we know that if a parabola is opening upward, then it has to open around the focus. So the focus has to be up at a point 9 above the vertex. And so the vertex was at 0, 0, so our focus has to be at 0, 9. Now that's just a placement of a dot we'll get to eventually, which we don't actually have to graph, but we can know where it would be. Then we have the directrix. The directrix we know is on the opposite side of the vertex, always. So once you know where your focus is and your vertex is, those are 9 away because of the value for p. So now you go 9 in the other direction, on the other side of the vertex, and that's where your directrix needs to be. And because this is a parabola opening upward, right? We know the directrix has to be a horizontal line below the parabola. It would not make sense for it to be a vertical line. So it's the horizontal line 9 steps below or 9 units below the vertex. So that would give us the horizontal line of y equals -9. Now, to graph this, we'll use our graphing tool. We will start with our vertex there at 0, 0. And so this is where we use the lattice rectum. And so the idea of the lattice rectum is this. You go up to where we said the focus would be, the point of 0, 9. The value for p, again, is 9. And what you want to do is you go 2p, so twice that value for p. So in this case, twice 9 is 18. You go 18 out, technically in either direction. Oops, I was not at 9. There's 9. You go 18 out in either direction. And notice, because it goes the same in both directions. If I click right there, I'll be getting a point that is 18 away from my focus on the right, as well as the symmetric point on the left-hand side, 18 points away. So again, to repeat, once you have your focus from the value of p, you go twice p out, and that will give you both points that are 2p away from your focus, and that gives you a much more accurate graph to your parabola.